you want to join?
Okay. Right. Thanks very much, everyone, for joining in. So my name is Erik Behrens. I'm a physical oceanographer here in Wellington at NIWA. And today I'm going to talk a bit about how New Zealand's oceans are projected to change over the next decades or so, and sort of tell a bit about what New Zealand's Earth system model had to do with that. Or it's a bit of outline for the presentation. So in the beginning, just a bit of what are the observed changes which we see or can measure right now, and then sort of just a quick taster about the Earth system model which was developed under the Deep South National Science Challenge, and then sort of talk you through temperature anomalies, and then something about temperature extremes, which some people might be familiar with, called marine heat waves, have been quite high profiles in the media over the last couple of years now, and then also show a bit of examples how actually this data from the Earth system model has been used for very practical policy applications. So I will just show a few examples here and then wrap up at the end. So this slide shows now observed changes around New Zealand. So left figure shows, apologies for the color scales maybe, but it looks very dramatic, but it is. Left-hand side, observed sea surface temperatures over 30 years of the satellite records. If you have really good eyesight, you can sort of read the numbers. So the ocean around New Zealand has changed on average by 0.3 degrees per decade over those 30 years. So it's very, very pink. And putting that into a global perspective, that means New Zealand's ocean warms roughly 2 to 3 times the global rate, if you take the global mean as a reference. All right, so why do we care? As every human, or as every living creature, marine organisms also have a thermal tolerance. As soon as you heat reach certain thresholds, organisms don't like it. Human beings tend to go to the beach, cool down during summer season. Marine organisms have a bit of an issue because they're already there. So they have 2 options. They can go further down into the water column, which is not good because there's less food, less light usually. Or the second option is to move south, which is shown on the right-hand side, where you can sort of translate the warming trend which we observe into a poleward shift of temperatures. And all the red colors indicate where temperatures move towards the poles. So basically, if you're a marine organism and you like to stay in your preferred envelope, you have to go further south. And if you translate those numbers, at the moment, that would mean you have to move 5 kilometers per year to keep up with climate change. And that is why we basically are also interested in temperature changes around New Zealand, also on global scales. All right, so the Earth system model, which we developed as part of the Deep South, is a standard CMIP6 model, basically, which is used for those IPCC initiatives. So we use observed carbon emissions to force the model, and then those future assumed carbon emissions to sort of drive the model and let the model predict how climate, atmosphere, ocean biogeochemistry, and all the other bits evolve in time, depending how much carbon we emit, so to give policymakers a handle on, okay, we actually have to do something here, otherwise we're gonna end up in places where we don't like to be. So an issue with those big Earth system models is that they are very coarse. So they basically divide the ocean into small grid boxes or very large grid boxes, which are shown in the UKSM figure. So basically, each grid box is basically where we would get data from. So they are usually 100 by 100 kilometers. And that usually becomes an issue if you are a regional council, somebody who likes to do aquaculture near shore, and then the next point, or they like to have the temperature at that certain location, and the only thing you can provide them is something which is 400 kilometers away, and they think, do those temperatures really match? No, they usually don't. So what we did in this model is basically something to refine the model. We refined the model grid from 100 by 100 kilometers to 15 by 15 kilometers, which allows to resolve coastal processes much better and actually provide stakeholders more localized predictions, how temperatures change in front of their doorstep, aquaculture facilities, or whatever. So how that in reality looks like, it's shown here in this animation, so hopefully it runs smoothly. So shown in color is ocean currents. So how the ocean is affecting water around. This quick refinement is just applied over the red frame, over this red box. So New Zealand is the center. So, and this unfortunately doesn't run nicely on the center mode. It looks very nice here, at least because we have this final model mesh. We are able to resolve those ocean currents much better than the coarse model would have otherwise. And that allows that ocean currents or coastal processes better resolved, leading to better predictions around New Zealand in general. So we basically, compared to the coarser version of this model, we were able to reduce model biases in those projections. All right, next animation. Sorry, that also probably doesn't run nicely only for everyone who is online. So then we can, of course, use this model and look into the future. So shown are here sea surface temperatures, how they progress in time. On the left-hand side, we have low emission scenario, medium emission scenario in the middle, and then a high emission scenario on the far right-hand side. And as you would expect, if we go forward in time, more or the ocean atmosphere warms more rapidly in the high emission scenarios in comparison to low emission scenarios. And that is basically what we're gonna find. And if you're a stakeholder here in New Zealand, you are concerned about, okay, what are we have to prepare for? And there is certainly a range depending on how much carbon we emit. So the New Zealand's ocean is going to warm by the middle of the century between 0.8 and 1.5 degrees based on those model predictions. And there will be a bit of a difference between what Australia experienced. So they have a bit more to cope with around Tasmania in particular due to changes in the ocean circulation. So in that regard, New Zealand seems like a good place. But at the same time, we have also something else. So that was the long-term change. Temperature change, but then we have those heat extremes, so heat waves, which come on top of the long-term change as well. So here again, it's a different metric. Those are the very short-term, high-impact events, which usually cause a lot of kelp die-off, coral bleaching in Australia. So they have huge impacts, and here we sort of experience, or the model thinks that those heat waves will become at least 0.25 to 0.75 degrees more intense compared to what we experience today. So over the past years or so, heat waves around New Zealand were roughly 6 degrees above climatology means, so that certainly adds a bit more stress to those marine organisms. And here, those simulations suggest that there will be no change between what Australia is going to experience and what New Zealand is going to experience at the same time. So we are in the same boat. It's not like, no, you guys are worse than we are. No, it's actually quite bad. And this is a slightly complicated figure. So we are looking here at probability. So how likely is, for example, a heat wave of 2 degrees, or how likely a heat wave of 2 degrees going to be? So this is shown by those distributions, those color shaded curves. So at the moment we are looking at the model thinks or simulates those blue shaded curves at the moment, and then we look into those different scenarios, and again look at the middle of the century and the end of the century, how this probability changes with time. And we see not just a shift, and that so a 2 degree heat wave just is 4 degrees by the middle of the century. And we actually see that the shape of the probability also changes. And that indicates that very high intensity heat waves become way more likely as we emit more carbon into the atmosphere. So that's basically the bottom line of this figure, which is very scary. Same applies for other regions around New Zealand. So another metric, instead of just looking at the intensity, which has an impact on marine organisms, is also the duration of those extreme events, how long they last for. Some organisms have shown they can handle a month of very hot temperatures, but as soon as it prolongs, then they certainly don't like it. And something which we identified here as well as marine heat wave days. So those are again those future projections with the system model show that the South Island is going to be one of those hotspots where we have going to see prolonged heat waves. So at the moment, the North Island around New Zealand roughly experiences 55 days on annual basis in heat wave conditions. South Island at the moment just 30, and future projections sort of suggest that we at least see a doubling of those heat wave days. And that is certainly something where anybody who does some marine stuff should care about. All right, and now just last but not least, also a bit of an outlook what model data has been used for to sort of bring it back more into the policy space. So those future projections have been used to provide data for studies which investigated species distribution. So where we try to investigate here in those examples, for example, where deep water corals might be and shift to as the ocean warms. So it's not just like also the model provided not just temperatures, but also pH, aragonite horizons. So if those corals, they need certain calcite and stuff to sort of form the skeleton, oxygen as well. And then they sort of predict where those habitats might be in the future. So there is this interesting aspect here, which is outlined in the last publication by Fabrice on the right-hand side, basically taking a few different layers into account. So the blue box shows where present current habitats are and how suitable they are for corals, for example. So the red box shows where how the habitat is going to change with the future. So this is informed by those projections of the Earth system model. And then you have different layers which come on top of that. So in the green box, that is sort of bottom fishing, so bottom trawling, where at the moment is a lot of bottom trawling and how that overlaps with the habitat. And then also in D shows where the value of the fisheries comes into play as well. And then you can map all that stuff together and ask, okay, where would be at the moment the top 10% to put, for example, protection around. If you are interested in keeping deep water corals, where would be your top 10%? And these are shown by those red shaded areas. And then we also can look into the future. Okay, with climate change, do those priorities change? Because the habitat changes and also fisheries might shift around as well. So then it becomes sort of an optimization exercise, as to say. So that is just one example, but there's more stuff in the pipeline, and DOC certainly has some strong interest around marine protected areas. Where should be good locations be for protecting marine species? And this is actually locations which are good now. Are they good in 10 years, 20 years time as well? So there is all sort of still in the pipeline and more to come here in that space. So take home messages. New Zealand's ocean is warming 0.3 degree per decade and is roughly 3 times the global rate. New Zealand has seen a large number of marine heat waves over the last decade, and this is and the trend will continue. So we will have more of them, particularly this year. So we are heading again into La Nina phase. So good for you guys if you like to have water sports. Not good if you're interested in finding power or interested in kelp. Marine heat wave intensities are projected to increase more strongly around the North Island, while heat wave days, so the duration of heat waves, will more strongly increase around the South Island. And at the moment, if you're a marine organism, you better keep pace with climate change. You have to move 5 kilometers per year to offset or stay in your thermal envelope. And that also applies for anybody who has fisheries interest, right? If you are interested where fish are going to be in a year's time, you have to have fishing vessels which always have to keep up with that shift as well. Yes, and then New Zealand's Ørsted model has been used, or quite, I think, very valuable, has provided valuable information for special planning, so giving DOC, MFE, and others some tools, some information where good places might be for aquaculture, marine protected areas, to keep or make the most out of New Zealand's ocean, basically. And those are my take-home messages. Thank you.
Thank you, Erik. There's a lot in there. I can imagine people's brains are really just working hard at the moment. I've just sent a few things to Phil. He's going to put them in the chat that outline some of the data from the marine heat waves and the NZSM oceans work. An outline of the work that Andrew was talking about sea ice, and also the research projects on our website. So Phil, throw those in the chat so you can have a look at them after this call. But just opening up the floor to any questions for Erik.
I do just have a question. I'm just curious about, I guess I don't fully understand the distinction between the New Zealand Earth System model work and what that tells us about the impacts in New Zealand as compared to the regional downscaling work that's happening. Are you able to just describe the difference and what sorts of things they're helping us to understand?
Yes, so basically there are two different initiatives underway. So there's the terrestrial downscaling, which you probably refer to, where CMIP projections of various models have been downscaled just using an atmospheric model. To example, look at river flows, precipitation, heat extreme on land. The Earth System model, which we developed in Deep South, had basically a built-in downscaling already included, but just for the ocean. So it has not done anything to the atmosphere. So this refinement has really just done for the ocean too, because we know a lot of, it's a maritime continent, right? So everything which happens in the ocean is, if the ocean warms, the atmosphere warms as well. So that was our priority at that point in time, to sort of focus on the ocean to make it as reliable as possible at that point in time.
It also, Karen, helps, as Erik's been talking about, this higher resolution ocean offers data that we don't have from other global models. So others are, hundreds of kilometers in resolution. This is a lot smaller, 25 kilometers. 20, yeah. And so it means that some of these studies, though this is one model, and looking at, all models in concert would be the best thing, because you have a look at the model into comparisons, and Andrew talked about that as well. But it does allow for a higher resolution for one model, at least, to look at these things like marine spatial planning that otherwise wouldn't be possible with the coarser resolution of the global models in the ocean. So yeah, there's a few angles.
I'd like to ask a question.
Absolutely. Sure. Which hat?
With the Commission head on. So the Commission is about to start working on the next climate change risk assessment. And you've given a really good example there about the deep water corals and some other work in the pipeline. Before that work comes to fruition, do you have a sense for where some of those hotspots that should be considered in a risk assessment might be? Are there areas where there's a larger, for example, larger regional change in temperature that's projected, or we know there's particular biodiversity hotspots, or
we know where the hotspots are, and we certainly know that they are under threat. So surprisingly, quite a bit of the Northland shelf also doesn't show a very strong warming than we would expect. So that is a good region for which sort of offers, if you something look for climate refuge, for example. And that is an interesting region which doesn't warm as much as many other regions around New Zealand. For example, there are other regions. Chatham Rise is at the moment off the charts. There's also, a small community heavily relying on fisheries. they are, at least the model thinks, they are not going to have the best time of their lives. I mean, all the heating also goes along with nutrients and algal blooms. I mean, it's just, you name it, everything is sort of linked to that as well. So there's some other hotspots. Fjordland seems pretty all right, thanks to the, basically they have a lot of deep water next to them. Unfortunately, they are sort of impacted sometimes by La Nina and El Nino events. But yes, there are certain regions which seem to be less impacted than others, but it needs a bit more investigation where they are and if that really holds, if we just look in another model as well and looking at some uncertainties. Yeah.
Is there any funding in place to do that research?
That was going to be my follow-up. Because marine heat wave risk, I mean, you know, long-term change is important. Marine heat waves are also important, and they're where a lot of the extreme events, I guess, happen in the ocean. And I know the Moana project has been working on this. Deep South has been working on this. Presuming Moana project is probably finishing relatively soon.
It's gone.
It's finished.
Gone.
So, is there any stable? This feels silly to ask in the current context. Is there any stable research funding for any of this work going forward?
None at all. Just sort of to clarify, so there is some hypothesis that certain organisms can slowly or can adapt to climate change. If you sort of incremental, everything gets slowly warmer and warmer, that is all good, and they can sort of adjust to that. But those heat extremes, that is where the high impact comes from. So we always hear coral bleaching, where 70% of the Great Barrier Reef completely turns white. And basically, we have the same here in New Zealand. We have sponge bleaching because we don't have those corals. But there's also, basically, there are high impact events which have shown devastating impacts on aquaculture facilities where salmon farms basically can't operate because salmon, they just die by heat stress, and there's the same for mussels and others. And at the moment there is interest in expanding, going further offshore, but at the moment everyone is sort of, this is a good spot. I mean, and then certainly you would have to know where those heat waves might occur and to sort of prepare or pick the right regions.
Maybe the right species.
Or choose the right species, yes, of course. I mean, might be. I mean, there might be some climate winners here as well, but at the same time, so in terms of fish space, snapper was always one of those. Oh, they are really good. They are warm, but at the moment, everyone had also some headlines about milky flesh snapper around Northland or so. I mean, it's not like there are winners here at the moment, or at least not straight away.